Precalculus Chapter 1, Section 4. In this section, we're going to review linear functions and their slope. Let's start by reviewing some different forms and characteristics of linear functions. The first is point-slope form, and it's descriptive because it's made up of a point x1, y1, and the slope m. So you can see the formula, just the general x and y. So it goes y minus y sub 1 equals m times x minus x sub 1. The second form is slope-intercept form, and that's made up of the slope and the y-intercept, and that's y equals mx plus b. In function form, it's f of x equals mx plus b. Just to review, the equation of a horizontal line is y equals the value that the line passes through. And the equation of a vertical line is x equals the value that the line passes through of x. And then finally, the general form of a line is ax plus by plus c equals 0, or ax plus by equals c. Sometimes that c term constant is written either on the left side or the right side of the equal sign. So let's look at example 1. Let's use the definition or the formula of slope and find the slope. So just to review that the formula of the slope is the difference in two y values divided by the difference in x's. So you can just arbitrarily name one of your points 0.1 and 1.2. And then you're going to subtract your y's over your x's. So we have a 5 minus negative 2 over negative 1 minus 4. That will simplify to 7 over negative 5. So our slope is negative 7/5. That means if that were a part of a line or a description of the slope of a line, that from one point to the next, it would go down 7 and over to the right 5. Here's different possibilities for line slope. Let's look at these graphics left to right. The first is a positive slope. You read a line like you read a book, left to right. So if your eyes rise from left to right, then that slope is positive. If, as you look at it from left to right, your eyes fall as you follow the line, then that is a negative slope. If your eyes stay level, then that is a 0 slope. A horizontal line has a 0 slope. If you're looking at a vertical line, we say that the slope of this line is undefined. So notice a horizontal line has a 0 slope. A vertical line has an undefined slope. Those are two distinct characteristics. Let's look at example 2 by writing an equation in point-slope form. So we're going to write an equation in point-slope form for the line with slope 6 that passes through the point 2, negative 5. Then we'll convert that to slope-intercept form. So there's the formula of point-slope form written for you. I'm just going to make note that m, or my slope, is 6, and rewrite that point 2, negative 5. I'm just going to label it x1, y1. Now when I put it in the formula, I don't replace anything for my general x and y, but I put in numbers for everything else. So y minus a negative 5 equals 6 times x minus 2. So there I've got it in point-slope form. I'm just going to clean up that and write y minus 5. Now I'm going to distribute and solve for y, and there's my equation in slope-intercept form. In example 3, we're going to write an equation in point-slope form for the line that passes through the points 3, 5, and 8, 15, and then we'll put it into slope-intercept. So the first thing we need to do is to actually find the slope. So I just name my first point 0.1 and my second one 0.2. And then I do my difference, so 15 minus 5 over 8 minus 3. So that's 10 over 5, or a slope of 2. Now I'm going to use the slope-intercept form to find my b value. I'm just going to use the first point, 3, 5. So I have the point 5 equals, the equation 5 equals 2 times 3 plus b, and then I solve for b, so b equals negative 1. Now in point-slope form, it's y minus 5 equals, well, you can see I make a little mistake. Can you find it? See how I did not put 2 in for the slope? I realize it because I was checking my work. So now I'm just reminding myself of point slope form, and there I've got the slope of 2 in. So there's my formula in point slope form using the 0.35. Now I'm just going to do some math, distribute that 2, solve for y, and there I've got it in slope-intercept form. Typically, we don't leave our linear equations in point slope form because slope-intercept is so much more helpful. All right, example 4, this is a quick review of graphing a horizontal line. It says graph y equals 3. This is how I always think of it, and I've been doing math a long time. I go to where y is 3, and I stay on 3. So no matter what x is, so if x is 3, y is still 3. If x is negative 3, y is still 3. So I've got a horizontal line right through where y equals 3. Example 5, let's find the slope and the y-intercept. So we're going to rewrite this equation that's in general form into slope-intercept form. Then give the slope, the y-intercept, and the x-intercept. But from general form, I think it's very easy just to solve or find the x and y-intercept. So I'm actually going to do those first. Remember, to find an x-intercept, we let y equal 0. So you're just going to plug in 0 for y and solve. And it's very easy to solve. It's just x equals 4. So there's our x-intercept. Now remember, to find a y-intercept, we're going to let x equal 0. So with that same equation, you'll plug in 0 for x and solve for y. So our y-intercept is 2, so the 0.02. Now I'm going to rewrite that equation in slope-intercept form, which just means I'm going to solve for y, and I put a little note up there. When you solve for y, put the x term first on the right side of the equal sign. The number in front of x is your slope, and then the number at the end of the equation is your y-intercept. So in example 6, let's use intercepts to graph a linear equation. First, let's find the x and y intercepts. So we're going to do that same process again. Find the x-intercept, we will let y equal 0. So you're going to plug in 0 for y. So 3x equals 6, so our x-intercept is 2. And then for our y-intercept, you know the drill, we're going to let x equal 0. So 3 times 0 minus 2y minus 6, and then just solve for y. So our y-intercept is the 0.0, negative 3. Now, it is easy to graph a line from the intercepts, so I'll rewrite those here, 2, 0, 0, negative 3, and graph them. And you only need 2 points to graph a line. So it's easy to graph a line from the x and the y-intercepts together. All right, let's do some final examples with linear equations. Let's find the equation of the line passing through these 2 points. So thinking of slope-intercept, those are the 2 things that we need to know to write an equation of a line. So I'm going to use my slope formula and have my difference of y's over my difference of x's. So my slope is negative 4/3. I'm going to use the first point I see to plug into slope-intercept with my slope and find my y-intercept, my b value, and that is 2. And now we can write the equation of the line in slope-intercept form. I usually use that form. If it doesn't indicate I need to use another one. Now number 8, let's find the equation of a line with the given x and y intercepts. I'm going to write those in terms of points, because if I have 2 points, then I can find the slope. And so I do my difference in y's over my difference in x's, and my slope is 8. Now I go ahead and plug in this second point, but if I would have been heads up, I would have realized that I already knew the y-intercept, and I could have just jumped right to writing the equation. But I didn't, so I just solved, and I now know that my y-intercept is 4. So the equation of the line is y equals 8x plus 4. On number 9, we're going to find the x and y-intercept and the slope. So you know I like to find the intercepts first from general form. So I'm going to let y equal 0. So I have 6x minus 5 times 0 minus 20 equals 0. So solving for x will equal 10/3. So that's the point 10/3, 0, which I will write in a moment. To find the y-intercept, I'll let x equal 0. So x times 0 minus 5y minus 20 equals 0, and then solve for y. So my y-intercept is -4. So I have the point 0, -4, and the point 10/3, 0. And then finally, to find the slope, I just like to, rather than use the slope formula, I'm just going to solve my general equation for y. And then I know my number value in front of my x term is my slope. So the slope of this line is positive 6/5. We can do the same thing in general terms. So I don't know specific numbers here with these 2 points in example 10, but I can still find the slope. So I'm going to take 0 minus a over b minus 0, difference in my y values over difference in x. So in general, the slope of this would be negative a over b, whatever those variables stand for. In example 11, let's find the slope in the y-intercept in general form. So to do that, I'm going to find the y-intercept first. I'm going to plug in 0 for x, and then I'm going to solve for y. So that means that my y-intercept is c over b. So I have the point 0, cb. And then to find the slope, I am simply going to solve the general form for y. So I subtract over my ax and then divide by b. I know that the term in front of x, the coefficient of x, is my slope. So my slope would be the negative a value over b. Finally, I've got general form again, but I have a -12 in there. And then I know that my x-intercept is -2, so I know the point -2, 0, and my y-intercept is 0, 4. So I can use those two values to plug in one at a time to find a and b. So I plug in -2 and 0 for x and y, and then I can solve for a. So now I know my a value is -6. I can plug in 0, 4 for x and y, and then solve for b. And so now I know my b value is 3. That concludes the notes for Chapter 1, Section 4, a review of linear functions.